All right, 20-1s. Here we go as we continue. Still pretty fresh, this whole idea of rational expressions and then eventually equations. Because we are dealing with rational expressions, which we quickly talked about, the fact is fractions, but with polynomials in numerator and polynomials in denominator. They look kind of ugly. We are going to this lesson simplify them. And if we think, if rational expressions are fractions, let's go back to something nice and easy, 25 out of 50. There's a fraction. What does it mean to simplify? It means to reduce, to make the numerator and denominator smaller, a little easier to understand. So that's what we're looking at doing here, is we want to reduce the numerator and denominator. And we're going to reduce them by a common factor. If there's something common in the two, a common factor, we can eliminate it from the numerator and denominator. Well, let's break it down and see how small we can make each of these rationals. I'm going to show the process behind it to review, and hopefully you will see a little bit and have a little bit maybe more understanding as to why the process works. Well, 15 and 20. If I took 15 and I split it up into parts, I could write 15 as 5 over 3. I now have two factors, 5 and 3. My 20, I could split up and create 5 times 4. This new rational has the same value but looks different. But when it comes to simplifying, well, the reason is we simplify is because there's a factor, a number that will multiply with both of them that's common. So we can get rid of it. And then we're left with 3 over 4. Now you see that a lot of, oh, you're just going to divide by 5, divide by 5. Right, you're dividing by 5 because you're factoring out a 5 from both. We're on page 3, by the way, in case you couldn't figure that out by what's on there. But the second one, 18m4n7 over 36m cubed n10. Well, if I want to simplify this, again, I want to break it into parts so I can get rid of as much as possible. Well, 18 and 36. Well, I can see that 18 is really 18. Why do I like the 18? Because 36 is really 18 times 2. So if I take my 18 and leave it as is and take my 36 and instead write it as 18 and 2, when we go to simplify, we now have a common factor. The m4 and the m cubed. Well, I want to factor out as much as possible. I'm going to be able to factor out an m cubed because there are m cubed and my m4 could be thought of as an m cubed times an m1. So by splitting my m4 up, I now have common factors that will cancel out. And then my n10 and n7, well, n7 is common to both, so I'm going to be able to take my n7 and cancel it with the n7 for my denominator that also has an n cubed. So do you have to show all these steps? No, but I'm showing you why it works. 18 and 36 reduced by 18 because that's the biggest factor they both have. M4 and M cubed can both cancel out by an M cubed because that's the biggest factor they both have. And N7 and N10 can both be reduced by an N7 because that's the biggest factor they both have. So if I reduce this rational, what am I left with? I have an m1 in my numerator, and I have a 2n cubed in my denominator. But I needed to break it into all these little parts to see what could be canceled out. And that's why this unit becomes tricky. We can't see those parts really well. So the first thing about simplifying rational expressions, everything we do this unit, it's all about factoring first. Because what a problem is that some students will see, they'll see, oh, I have a 3x and an x. Well, I can cancel the x's out. But you can't. Because those x's, they're not factors. We have an x which is part of a term in that binomial, and we have an x which is a term in that trinomial. These aren't factors. We can only cancel common factors. And that's why step 2 is going to be so important as well, is common factors, you can cancel single term monomials with monomials. We can cancel a monomial and a monomial. And I can cancel a binomial with another binomial. But I can't cancel parts of these things. Oh, look, there's a 6 and a 10. Let's reduce those by 2. No, I can't do that. Yes, 6 and 10 have a common factor of 2, but 6 and 10, they're not factors. I can only cancel factors. The 6 and 10 are terms within the polynomials that are there. But I have to cancel things that are factors, not just parts of a factor. So let's take a look. Here we go. 3x minus 6. Can we factor it? Factoring. You need to consider GCF factoring. You need to consider simple trinomial factoring. You need to consider decomposition of complex trinomials. And you need to consider difference of squares. These have to be second nature to you. So 3x minus 6, we can GCF factor that. GCF factor, there's a common factor of 3. Divide each term by 3, and we're left with x minus 2. So now I've broken it into some factors, more to work with. Our 2x squared plus x minus 10. Well, that's a complex trinomial. So you're going to need some scratch paper in this unit. 2x squared plus a 1x if it helps, minus 10. Here we go, complex trinomial. We want to multiply to get negative 20, but we want to add to get that 1. We've worked with this already this year. You worked with it last year. This semester, or this chapter, you're going to work with it a ton. What's the combination here? Combination is 5 and negative 4. So 2x squared plus 5x minus 4x minus that 10. Our 1x has decomposed into those two parts. Pair up our 4 terms and factor out whatever I can from each pair. Here I factor out a negative 2, so that when I divide, I end up with 2x plus 5. That's what I need. The same thing in brackets. So we have 2x plus 5 times x minus 2. There's our factored form. So we're going to have to do all kinds of factoring within this chapter. So we factored the polynomials. Now I look at the factors, like I was just talking about. We have a factor of 3 and another factor of x minus 2. Here we have a factor of 2x plus 5 and a factor of x minus 2. I can't cancel parts of those. If I want to cancel something, it has to be a factor all by itself. Well, in this case, are there common factors? Yes. X minus 2 is a factor in both of those expressions. So they cancel out. That leaves us with 3 over 2x plus 5. And so this initial expression can be simplified to that expression. It means the same thing, it's just a simpler version of it. So we wrote it in the simplified form. But from lesson 1, we now need to know what are our NPVs. Well, careful, because NPVs can occur anytime in an expression. So I have to be careful. I don't just list the NPVs for my final value. I need to list also the NPV in that first factoring step. Because if I had a zero value here, this expression would be undefined. So you need NPVs for any point in the expression. So one possibility for an NPV is if 2x plus 5 equals 0. Now subtract 5, divide by 2, and x cannot equal negative 5 halves, because negative 5 halves would give a denominator of 0. But the other one's true over here. If x minus 2 equals 0, because x equaled 2, we can't have x equal to 2 either. So our NPVs for this original expression, the NPVs are if x equals negative 5 halves or 2. Those are the non-permissible values. X can't equal that, x can't equal that. There's the simplified expression with its NPVs. Here's the second one on page 3. Well, here we go. What's the first thing? We want to factor the polynomials. Well, hopefully this top one actually looks familiar because it's the one we just did. So we can cheat a little bit if we want and just list that particular one as the 2y plus 5 times the y minus 2. The second factor now form, I need to factor the bottom trinomial, simple trinomial, so I need two numbers that multiply to negative 10, but add to 3, factored form here. What multiplies to negative 10, but adds to 3? Well, that's positive 5, negative 2. So we have y plus 5 and y minus 2. We factor the polynomials, and now we cancel common factors. Again, common factors. Y minus 2, look, there's another y minus 2 factor. Those will cancel out. So we end up with 2y plus 5 over y plus 5. As I talked about, people wanting to cancel too much, oh look, the 5s will cancel. But I can't cancel those because the 5s are not factors. We have to cancel factors. The 5s are terms in those factors. They can't be canceled. So there's our simplified form. And again, after we've written the simplified form, list the NPVs. In this case, we need to consider NPVs everywhere. So NPVs will occur if y plus 5 equals 0. So y cannot equal negative 5. It will also happen if y minus 2 equals 0. So y cannot equal 2. The NPVs are when x equals negative 5 or 2. Those are not allowed for that simplified expression. Now, this particular one, you want to star. I skipped it, and I came back to it. Gotta watch lots of little things in this unit. 1 minus t, factor it. We can't factor it. There's nothing to factor. Denominator, t squared minus 1, two terms being subtracted. Square root is a t, square root is a 1. So we can end up with t plus 1 times t minus 1. Now 1 minus t is a binomial. It's a factor all by itself. The problem is we have almost common factors, but not quite. Common factors, almost. Because if we look at that, 1 minus t and t minus 1 are close to being the same. But here it's a positive 1, but a negative 1. A negative t, but a positive t. So I need to switch the signs. Well, what's going to switch the signs? Switching signs is if I put a negative out front. If I multiply this 1 minus t by a negative, that changes my signs. So negative out front now becomes negative, negative 1 plus t. I haven't changed the value of it. It's like I divided by a negative 1. I just changed how it looks. What's the value up top? It's still a positive 1, and it's still a negative t. But by putting that negative in there, I've just given myself a different form, because now with this t plus 1, t minus 1, oh, t minus 1 is like a t and a negative 1. There's common factors, and we can cancel those out. And once they're canceled out, what are we left with? Well, all we have up top is a negative, so that would be a negative 1 over t plus 1. There's our simplified form, but we still need the NPVs. And NPVs occur for those two expressions. If t plus 1 equals 0, that's a bad thing, so t can't equal negative 1. If t minus 1 equals 0, that would be a bad thing, so t cannot equal a positive 1. NPVs are when t is equal to positive or negative 1. Those are going to create a 0 in the denominator, which would be bad. So, a couple more here. Let's go to page 4. Give this one a try. Pause it, and then we'll come back. A little bit of factoring, and a little bit like the example we just did. Try it, and then we'll see how you make out. So here, simple factoring is GCF. We can factor out a 2, which leaves us with 3 minus m. Here, on the bottom, difference of squares. M squared can be square rooted, 9 can be square rooted, 2 terms being subtracted. We're left with m minus 3 times m plus 3. So there's, after the factoring, we now have factors. Is there anything common? Again, it's close. Here we have a positive 3 and a negative m. Here we have a positive m and a negative 3. These have the same things but the wrong signs, so what can we do? Let's change our 2 to a negative 2, which will change the signs on our terms in the brackets. Negative 2 times negative 3, that's still our 6. Negative 2 times m, that's still our negative 2m. We have the right value up top, but now we also have a negative 3 with an m, a negative 3 with an m, a common factor. What are we left with? Negative 2 over m plus 3. There's your simplified form of the original expression. Finish off. NPVs will occur if m minus 3 equals 0, therefore m cannot equal 3, or if m plus 3 equals 0, so m cannot equal negative 3. NPVs, 3 or negative 3 for m. So it's factoring, looking for common factors, and canceling them out. Page 4, give it a try, see what you come up with. (16x squared minus 9y squared over 8x minus 6y). Up top, 2 terms being subtracted, both square rootable. we end up with 4x minus 3y times 4x plus 3y, difference of squares. Down in our denominator, all we have is a greatest common factor of 2, which leaves us with 4x minus 3y. 2 times 4x minus 3y. Is there anything common at this point for factors? There is. 4x minus 3y. So we end up with a simplified form of 4x plus 3y over 2. And NPVs, because we have an x and a y, in this case, with two of them, there is nothing that's going to limit us. Unless x and y both equal 0. Those are the NPVs. It's the only time. Otherwise, an x value and a y value that's other than 0 is going to give us something we can work with. There's your simplified form. So, what we are looking at is the assignment for this particular lesson, textbook, page 318. Lots of questions, looks like a lot of work. It's all about the factoring. Can you factor efficiently is the first thing, and then can you cancel effectively? Factor efficiently, cancel effectively. Make sure you know what you can or can't cancel. That's all there is to it. Lots of little steps. You're just going to get more. Enjoy the work. Have a great day.